to see done? Happy to do things? Number 11. Sure. Okay. So this is 11. Lexi, what did you want to do first here on number 11? That's good. Okay. Then what did you do? Yeah, good. So again, the phrasing that we use there isn't multiplication. It's yeah, you're doing the reciprocal exponent. So that's going to cancel out the exponent on the left-hand side. And then if I just go in my calculator, I can do 16 to the 3/2. That gives me 64. But keep in mind something at this step. Yeah, so Zach says we need a plus or minus here because we actually did an even root to both sides. So that should be plus or minus 64. Okay, and then what should we do from here, Lexi?
I don't know.
Well, it's easy now. We're just going to subtract 43 and then divide by 3. Now, the catch here is that I can't subtract 43 from a plus or minus 64 directly, right? So if I do negative 43 plus 64, that's going to give me 21. If I do negative 43 minus 64, that's a negative 107.
Okay, so your first has to be 7, this to be negative 10, negative 107.
Yeah. So that's going to give me those two solutions. Nope, just those two, because we already did the plus or minus when we did the split here. Cool? That's a good question. So how to deal with the plus or minus there is an important one, right? That we're able to kind of handle that. Okay. Any others? Questions? Happy to do more if there's more. 7? Sure. Okay. So first thing I would do on this one is to add 8 to both sides. Okay. And the second thing we should do is, yeah, let's do negative 4 though, because it's a negative 1/4. But yeah, we're getting rid of that negative 1/4. So whether you want to think about it as dividing by negative 1/4 or multiplying by its reciprocal, either way of thinking about it is fine. You're doing the same thing. Is everybody okay to there? Okay. Now let's get rid of the radical. So we'll cube both sides. So the cube is going to cancel out the cube root. And then to get negative 48 cubed, I'll just do that on my calculator. Negative 48 to the third power is 110,598. Oops, I meant a negative 110,592. And then we'll subtract 10 from both sides. That'll give us negative 110,602. And then we'll multiply both sides now by 4/3. And when I type that into my calculator, I get the negative 147,469.3 repeating. Is that good? You're welcome. Anyone else? Questions from this assignment? All right. So let's move on here. Today we're going to talk more about solving radical equations. So today we're going to just look at some more situations that we can run into when we're trying to solve these radical equations. The situations we're going to worry about today are a bit more complicated than the ones from last time, so we really need to make sure that we're kind of engaged and paying good attention. But it's usually fairly easy to identify these situations that are a little bit more complicated. So let's say we have x plus 1 equals the square root of 7x plus 15. How is this problem different than the ones that we saw yesterday in the homework? Good, we have x in more than one location, right? That's going to be common to all the problems that we're going to look at today, is that we're going to have x's in more than one location. And there's going to be kind of three different kinds of those problems that we'll run into today. So my first order of business when I have a problem like this is to isolate a radical. Well, that part's already done for us because we have a radical alone on the right-hand side. So we're good there. My next step then would, once the radical's been isolated, is to cancel out the radical. So how am I going to cancel out 7x plus 15, or the square root of 7x plus 15? Square both sides, right? Just like we've done before. So we'll do that. The square cancels out the square root. And then what's x plus 1 with the parenthesis around it squared give us? Very good. So Luis says that this is going to be something we have to FOIL out. Remember that x plus 1 squared is really x plus 1 times x plus 1. So we have to make sure that we FOIL here. So x times x is x squared. X times 1 is x. 1 times x is x. And then 1 times 1 is 1. And if I combine like terms, I have x squared plus 2x plus 1. What kind of a problem do we have now? It's a quadratic equation, right? Very good. What's the first step in solving a quadratic equation? What does it have to equal? It has to equal 0, right? So what I'm going to do is I'm going to subtract 7x from both sides and 15 from both sides to make this equation equal 0. Now, first semester we talked about 3 different ways we can solve a quadratic equation. Does anybody remember any of those 3 ways? The quadratic formula is one. What's another? Well, I mean, okay, we did that this semester though. But yeah, who would use synthetic division to solve a quadratic? Come on, I'm talking about
crazy people.
using a bazooka to kill a fly here. Like, that's a pretty powerful tool for such an easy problem. You could factor. right? That was one other technique we used. And the third one was we can solve these directly if we have only x squareds, right? If we don't have any regular x's. Now, that's not the case here, right? We can't solve this one directly because we have both x's and x squareds. What's going to be easier, using the quadratic formula or factoring this one? Factoring this one. Should be easy to see that this factors. We're just looking for two things that multiply to give us negative 14 and add to give us negative 5. Zach says it's negative 7 and positive 2. Couldn't even let me finish before he was yelling at answers out. That's good. You don't have to apologize for knowing the answers. Everybody's happy with that? And once we're in factored form, we can set each of these equal to 0 and solve. So when I add 7 to both sides, I get 7. And subtract 2 from both sides, I get negative 2. Am I finished? No. What do I still need to do? Yeah, I have to check this problem because if I go back and I look at the original problem, this is an even root, right? So we're going to have to check those two solutions. I'm just going to use my calculator to do that real quick. So the way that I'm going to do this is I'm going to plug in x's for the left-hand side and the right-hand side and see if they give me the same value. So for 7, I get 7 plus 1 is 8. And then I get the square root of 7 times 7 plus 15 is also 8. So 7 is a solution. Now let's try negative 2. So I plug negative 2 plus 1 is negative 1. And already I know that that's not going to work, but let's just show the rest of it. 7 times negative 2 plus 15 gives me positive 1. Those did not agree. So I'm going to cross out the solution of negative 2. And we're going to accept only x equals 7. Is everybody okay with how we checked there and how that check worked? And again, perfectly fine to just do all of the check on the calculator. You don't have to write anything down for that, but you need to make sure you're remembering to check because especially today, you're going to run into many problems that have extraneous solutions. Let's do another of those. That's a little bit tricky. Let's try to do another. So square root of 10x plus 9 equals x plus 3. First step is to square both sides. So the squared cancels the square root. And then for x plus 3 squared, what do I have to do? I have to FOIL here. This is a number one place where students in this class make mistakes, is just writing that as x squared plus 9. That, as we discussed yesterday, is never going to work. That was the freshman's formula. We don't want to do that. We're not freshmen in here. So when I start foiling this out, x times x is x squared. X times 3 is 3x. 3 times x is 3x. And then 3 times 3 is 9. If I combine like terms then, I have x squared plus 6x plus 9. And then to solve this quadratic equation, which is what we have now, we need to make it equal to 0. So we'll subtract 10x from both sides and 9 from both sides. In general, when I do this, I'm always going to do the subtraction so that the x squared is positive. Just makes the factoring a little bit easier if that's what I choose to do. One less negative sign rattling around in the problem. So I have 0 equals x squared minus 4x. Can't solve this directly because I have x's and x squareds. Would it be easier to factor this or use the quadratic formula? Well, the factoring doesn't get much easier than this problem, right? Since I have no constant term, I can just take a greatest common factor of x out, and that thing is factored. So I'll set each of the factors equal to 0. So one solution is x equals 0, and the other solution I get by adding 4 to both sides, and it's 4. What can't I forget to do? Check them. All right. So let's check these. So let's check 0 first. So I have 10 times 0 plus 9 gives me 3. And then 0 plus 3 gives me 3. So 0 is a solution. That one worked. Now let's check 4. 10 times 4 plus 9 gives me 7. And then I have, 4 plus 3 also gives me 7. So that works. I have 2 solutions in this case. Is everybody okay on that? Again, a little bit more than what you had to do yesterday, but a couple of times of practice and it should be fairly easy. It basically boils down to solving a quadratic equation at the end. Let's look at another kind of problem. So let's look at this situation. How is this different than the previous 2 examples? We have x's under in 2 different locations, but both x's are under square roots, right? Okay. What do you suppose the first thing I should do is? Square both sides. So when I do that, the square cancels the square root on both sides. And we're left with 2x plus 5 equals x plus 7. Doesn't get much easier of an equation to solve than that. That's just a linear equation like we would have solved in our Algebra 1 class. So I'll subtract x from both sides and subtract 5 from both sides to get x equals 2. Am I done here, though? No, still got to check. So I'll do that again, and I like to use my calculator to check. You can do it by hand if you want to. I don't know why you would. When I check the left-hand side, I get 3. And then when I check the right-hand side, I get 3. So this answer is good. Everybody okay there? So that situation's quite easy, right? That's the easiest situation we'll see today. Let's look at this next situation. How is this situation different than the previous one? Yeah, we have this extra plus 1 rattling around out here, right? Do you think that's going to make a big difference or a little difference? It doesn't seem like it's going to matter that much, but boy, it makes the problem much, much harder. So, just like we did before, probably just going to square both sides to start. So, on the right-hand side, the square cancels the square root, and we're left with 3 minus x. On the left-hand side, what are we going to have to do here? Can I just write that as the square root of x plus 2 squared plus 1 squared? Nope. What do we need to do instead? FOIL. Yeah, so this is where that that plus 1 makes life a pretty big pain in the butt, because now we have this really unfortunate looking foiling problem going on here. But it's not that bad. We'll just FOIL like we would normally. So I have the square root of x plus 2 times the square root of x plus 2, which gives me the square root of x plus 2 squared. Square root of x plus 2 times 1, which is the square root of x plus 2. 1 times the square root of x plus 2, still just the square root of x plus 2. And 1 times 1 is 1. Everybody happy there? All right. So squares can cancel the square root. That gives me just a regular old x plus 2. I notice these guys are the exact same radical, right? So I can add these together by adding their coefficients. That gives me 2 x plus 2's. And then I still have that plus 1 on at the end. I notice on the left-hand side there's still some like terms to add. So 2 plus 1 is 3. Everybody's okay to hear. I'm now going to try to turn this problem into something like we saw in the first two examples. So I'm going to try to isolate the square root now. So to do that, I'm going to subtract x from both sides and subtract 3 from both sides. That's going to give me 2 root x plus 2 equals negative 2x. What should I do now? Divide by 2. I want to isolate that radical part, so I still have a little bit more I can scrape away off that left-hand side. Now the radical's been isolated. My next step would be to square both sides. It's not a very good looking 2. So the squared cancels the square root, and then negative x times negative x is just x squared. I'm going to move everything onto the same side so that I have a quadratic equation that's equal to 0. How do you want to solve this quadratic equation? Let's factor it. Great. So what two things multiply to give us negative 2 and add to give us negative 1? Negative 2 and positive 1. That's good. And when I set each of those equal to 0, I can add 2 to both sides to get 2. And subtract 1 from both sides to get negative 1. Am I finished? What do I still need to do? Still got to check. Jeepers creepers. So if I check with positive 2, I have root 2 plus 2, and then plus 1 on the outside. That gives me 3. And then I have root of 3 minus 2. That gives me 1. So 2 did not work. Let's try negative 1 then. So I have square root negative 1 plus 2. And then plus 1 on the outside. That gives me 2. And then I have square root 3 minus negative 1. That also gives me 2. Those matched, so this is a solution. Is everybody okay on that? Let's do one more of those just to kind of hammer that process home. It's kind of a lengthy one, right? On letter E, is that right? I think so. I don't know. It's hard to keep track. All right. Square root of x plus 6 and then a minus 2 equals square root to x minus 2. First thing I should do is square both sides. On the left-hand side, we have to FOIL. On the right-hand side, the squares cancel the square root. Now I'm left with just x minus 2. So when I FOIL this out, square root of x plus 6 times the square root of x plus 6 is just x plus 6, right? Everybody's good with that? We can see how I canceled to get there. Yeah. Square root of x plus 6 times negative 2 is negative 2 square root x plus 6. Negative 2 times the square root of x plus 6 is negative 2 square root of x plus 6. And then negative 2 times negative 2 is positive 4. I'll combine my like terms on the left-hand side to get x plus 10 minus 4 root x plus 6. And now I'll begin isolating that radical. So I'll subtract x from both sides and subtract 10 from both sides. And if you notice, something quite nice has happened here. What do you notice happened? Look at our x's. There's just one of them now, right? We lost that second x. That has changed this problem fundamentally. This is now like one of the problems from last night's homework, as opposed to those first two examples where there's going to be no quadratic equation necessary. Pretty nice. All right, continuing on, let's finish isolating the radical now that we've made that little observation. And then I can square both sides. This is where not having that second x really pays some dividends, because the problem we're left with, we can just subtract 6. Oh my goodness, guys.
Sounds like you could use a snow day.
I wish I was in charge of it. Is this our final answer? Still got to check. So, checking the left-hand side, I get 1. And then checking the right-hand side, I get 1. So this works. And that's my answer. We're going to stop here.